to have. You know, C is not a perfect language.
Hello, hello. How's it going? How's it going? Welcome back to yet another stream. I thought of streaming uh, since afternoon, but then I spent time to clean up my desk. Uh, Clean up my desk a little bit, and mostly spent time watching The Family Man. We finished it off. It was a nice series. I liked it. I changed the camera position a bit, so I do want to hear how I am sounding. So I'm sorry if you hear an echo for a second. But, and we mostly spent time watching. Okay, I think the voice is good. Hello, everyone. Welcome back to the stream. How is your Sunday going? How's your Sunday going? Okay. With time, probably people will join. So what I'll do is I'll get started. And yeah, the reason why I did some cleanup and everything is because I ordered a new monitor. So I finally decided to go with a second monitor and not with a 32-inch monitor. The reason for that is then I can monitor my chat and things like that on the other monitor, and hopefully my productivity will increase, even for a work perspective, right? I haven't though decided yet how I want to keep a. So I have a 27-inch monitor, so I think I will keep it vertical, but vertical becomes too high. So I don't still know how we're gonna do that, because I still want to sit in the middle of the table. It's just like, I don't know, it just feels wrong, and I want to straight look at my monitor, not the other way. So if I put the other monitor in a very different position, it's gonna go out of my table, which is fair, I think. Or I can put it in a swivel manner. We'll see. We'll figure out once it reaches tomorrow, or maybe I'll just put it in a vertical mode. So I've been planning for this for quite some time, and I was thinking if I should get a 32-inch second monitor. Then my friend finally bought a second monitor, and I decided, okay, maybe I should do the same thing too. So yeah. Okay, I think the light needs to go a little bit like this. Okay. So anyways, welcome back to the stream. And what are we doing tonight? So tonight we are working on learning some algorithms. I thought of continuing with the Python stream, but yeah, since I started so late, I thought Sunday I'll stream in the afternoon or something. But then entire day we lazed off. We got some work done, and mostly my wife got some work done. I was lazing around, but I got my table cleaned, which is still okay, I would say. But yeah, saying that, I think it's now time that we get started. Just a second. Oh, this thing came off too. Okay, so I need some more one-sided tape, I guess. Double-sided tape, I guess. Okay, cool. So, how's it going, chat? How's it going, everybody? So let's start with something. I just looked into LeetCode, this thing, daily stuff, and I saw that I have not finished that, like not today. And apparently, I also tried to stream it before. So yeah, but I apparently tried to solve it before and attempted wrong, and I just saw that I tried to solve it like almost a year back, right? 2024 October. So let's see if we can solve it today. Okay, let's see if we can solve it today. Okay. Given an array of positive integers, nums, remove the smallest subarray possibly empty, such that the sum of the remaining elements is divisible by b. It is not allowed to remove the whole array. Return the length of the smallest subarray that you need to remove, or -1. Okay. So 3, 1, 4, 2. So this is 0. So if you take the prefix sums, this is 3, this is 4, this is 8, this is 10. The total sum is 10. If I need to make it divisible by 6, and since I only can remove stuff, what do I have to say? I think I just have to return the length of the smallest thing. So I have to remove something like 4. Right. So what I think is going to be the answer is that if I have an element 4, I can simply remove that. So here it would be 1. But if I didn't have an element 4, what I would have tried to see is that if there's a subarray length of 4, but that has to be the minimal one. It has to be the minimal one, right? And how do we check if the length of the subarray? So we keep everything in a map, since we have to get the index. We keep everything in a map, and whenever we go there, we try to find if the complementary is there in the map. If the complementary is there in the map, it means that for +1 till that particular point, I can generate that amount of size, right? So as an example, if I say 8 minus 3 is 5, so 3 is here, so this one will be 5, right? So this is what I mean by. So this is how we are going to try and figure out what is this. But only thing here is that since the array is small, since the subarray length is minimal, we have to find a minimal length. What we do is whenever we find a value, so it doesn't quite say, oh, it's always positive integers. So it cannot be 0, I think. Yeah, it cannot be 0, which means, okay, we don't have to worry about that, because if it was 0, what we had to do was we had to say like we had to overwrite the index, or if it was negative, because it can go to 4, then it can go to 2, then, so as an example 3, right, it can go to 3, it can go to 0, then it can go to 3 again, because the value is 3 minus 3 plus 6, right? So then it can come back to 3 again. So the complementary for 3, I would take this one and not this one, because I want it to be the minimal, right? But here, since everything is positive, that won't be necessary. So I think that is what it is, right? So let's try to solve the problem in that way. Let's see if that works. I don't know how I tried to solve it before. Sorry. So first thing first, we have to get the entire sum, right? To get that entire sum, we can do this thing. Total sum is 0. Then there is a map in which this map put the sum is 0. Look at that, auto completion already knows what I want. Okay, so now for int I this thing, total sum is this, map put total sum and then I. Well, we don't have to check if it's there because, like I mentioned, it says that it's a array of positive integers and not zero. So the sum can never be the same, right? The sum can never be the same. Okay. So the total sum int remove. How much do we have to remove to make it divisible by p? Sorry, it has to be total sum mod p. Total sum mod p, and that would give us what needs to be removed. If something needs to be removed, either an element is present or we have to try and find the corresponding thing in here, right? So if remove is 0, we can say return 0 because we don't have to remove anything. It's totally divisible by that number. All right. If nums of I is equal to remove, I'm just gonna say return 1. Removing one element is sufficient. So that is what it is, right? So that is what it is. Okay. The next thing, what I do want to do here is that, so at this particular index, at this particular index, what is the sum? Map get index in complement should be sum minus remove. We could have inlined that, but it's okay. It's also easy for us to understand what's going on. Okay, and after that, what I can simply say is that map dot contains key complement. If this is the case, so we're gonna get this I minus this thing is the length. Well, not really, because if I was as 8, this would have been 0, 1, 2, and this would have been 0. Yeah, so I can just say this is the length that we need to be removed because technically speaking, this is the part that right. Well, min length cannot be that. So let's do -1. That's much more easier. If min length equal to -1 or length is less than min length will be equal to length. So if it never changes, it's gonna return -1. That is exactly what we wanted here. So I think this should now work. Let's see. Hopefully it does. Fuck. We are doing the other way around. I'm stupid. So what do we do here? Yeah. Well, we can do two things, honestly. We can do two things. I mean, for now, we're gonna make it work like sum to index map. And then here you can say this is index to sum map, right? And in here, index to sum map, you say the other way around. Total sum, right? And in here, how do you get this sum at index? You can simply say index to sum map dot get I. That should give us still O of 1 amortized lookup. Why did it say 3? But if you remove everything, so the answer cannot be remove everything. Is that what you're trying to tell me? So as an example, if I say one of the test cases is 1, 2, and 1. If you say this, and P is 5, what is the answer that you're expecting? You're expecting -1. Okay. That should fix that. Still a wrong answer. Of course. We didn't see the bounce. That's wrong of us. Of course, we didn't have that. We have to be a little bit careful about overflow and all that. Man, holy shit. What is the total sum of this thing? $70. Do you not have anything which can make 17 is the question. What I can simply do here, I think, is just replace this guy with this guy. All right. So this is a dictionary. And value. Let's say index and how do you do index and value in p dot keys for I did it wrong. P dot keys. So you have to say enumerate And then in here for j underscore v in enumerate is, wait, did I put an extra? I think I put an extra. If I equal j, simply continue, we don't consider that, else print right? Okay. Do we have a difference of 17? We don't. But I get it what the issue is. I do get it. My logic is wrong. So here what we do is we try to bring in the thing closer to divisible by 17, but where is it? Whatever, like divisible by p, but so let's say the value was x and you're trying to divide by y, and to make it divisible by y you have to subtract a here, which then kind of becomes divisible by y, a 0, right? Mod becomes 0, which means it's divisible. But the problem here is that we are considering the fact, so let's say that there is no a present in the subarray, but it doesn't quite tell you that there is supposed to be a b which will make this thing happen, where b is greater than a, so we can subtract a bigger number. We didn't consider that. Sorry. So as an example, so the total sum here is 225, right? Which we are just considering how much was, we are trying to find 17, but no one said that I cannot find 17, but I can find something like this, which is 43. So is there a 43 in here, by the way? There is a 43 in here. So I guess this is where it went wrong. So we have to change our approach. Our approach is wrong. Okay. One of the things we can do is we can say this is 0 and this is 3, this is 4, this is 8, this is 10, as and when we go. So when we reach 3, when we generated 3, we can try and traverse till here. Alright, so first we try and find out the entire sum, then we do the same thing again. We traverse the array again. Good. And we try to find that if we subtract it, like this much, if you subtract 4, if you subtract 1 from the total sum, can it be divisible by b? And if it becomes divisible, we can say, okay, try to find the minimum. I think that is another approach. I mean, that's the correct approach to be done. But I don't know whether it will be a, yeah, essentially bar 5, which means it's going to be a time exception. But let's actually first make it working, right? For even, like right now, it doesn't work for this. So let's make it working for this. Right. That's going to be the goal. Okay. So you don't need this. I'm just going to remove everything for now. We also need the index to some map. So it has to be indicated to lock. I quickly want to see what does this thing do. So I have 26 and 1, and I have to divide by 27. Are you expecting -1 or 0? You're expecting 0. Okay. We don't need the total thing, right? If total sum b is 0, it's gonna return 0 for now. Now, right here. Oh, we haven't done that. Okay, hold on. Why do I need this? I don't think we need this for now. We don't even need this since we're already doing an iteration. We don't even need this, honestly. We don't even need this. Right. एक मिनट just a second. I will be quickly back. Just a second. Just enjoy some music till then. I'll be back. Okay, we are back. Hi Shubham. Hi Shubham. Hello, hello, hello. Welcome to the stream. Welcome to the stream. How are you doing? Dude. Yes, dude. Tell me, dude. What's up with you? How are you doing tonight? Hmm. So, mm, I didn't get what just happened. The animation shows how the letters are in a text are normally stored using the feet. And how often go? Count how often each piece of data occurs. Build a binary tree starting with the nodes with the lowest count. The new parent node has combined count of its children. The edge from a parent gets 0. The new parent node has the combined count of its child nodes. Starting with the nodes with the smallest count. Okay, so you took the nodes with the smallest count, O and E, and you build something on top of it. After that, L comes, you build something on top of it. After that, an S comes, you build something on top of it. Okay. In the finished binary tree, follow the edges from the root node, adding 0 or 1 for each branch to find a new half-line code. Okay, so after that, so this is 0, this is 1, so this is 0, but then it's 1, 0. So here it's 1. Okay, I get it. But we have to do this. We have to do this in a. in a packed manner so that it's like compressed. Otherwise, if I start creating um, string builders, it would be huge, right? So that's one thing. Okay, I think I understand the algorithm a little bit. Hopefully, found invalid configuration. Okay, what is your valid configuration, friend? Uh, what is the Gradle version that I'm using? I have to select this. SDK RN. Gradle. Does it say which version? 910. So here, I suppose if I just say 910, does that work? Mm-hmm. In build Gradle, I'm saying this. This is something that I don't want, I suppose. Okay. So now, okay, the jar got upgraded also. That's kind of good. I think Gradle.properties is not required in my opinion. Okay, but if you just go to build Gradle, here you have a bunch of things, but I wanna change this to. Holy shit! I have so many things. Why? I don't know why I have so many things. Okay, that failed. So suppose I was using something weird in here, an inter-array converter. So let me just quickly set up 25 open, remove this. Hmm. Okay, this looks like a dead project. I don't want to do this. Let's do it here. Right, Gradle init. It's basic. No. Oh, thank you so much. Someone is spamming hearts. Thank you. Uh, you just say hello, but okay. Uh, welcome to the stream. Welcome to the stream. What was I thinking of doing? I forgot. I thought of we can do it ourselves also. It's not a big deal. Hello, Lucifer Devils Boy Gaming 601. Hello, 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 Lucifer. Welcome to the stream. I'm sorry, you guys. The names don't come up anymore. It's just your YouTube handle, so I can see that weird name. Um, yeah. Hello, welcome to the stream. How's your Sunday going? Okay, so what I do want to do here is you can go to Algo Expert. And I'm sorry, I'm a little bit tired after today's work, but yeah. We can copy paste this and we can just pull this in. Now you're spamming he. Okay. Okay. Cool. I think this is supposed to be it. Okay. So let's first understand that what are we trying to do here, right? So we're trying to first let's do this. LeetCode lossless, sorry. Motherfucker. Okay, we're gonna type it. So you have LeetCode. All right. And L is 2. Oh, we are doing LeetCode. Okay, hold on. L is 1. Both looks like the same. E is 1, 2, 3. And there is D which is 1. Then there is C which is 1. There's O which is 1. There is D which is 1. You have to take two pairs, two characters which are the lowest. Which are the lowest, right? So we can take L and T. So we create nodes out of it where this thing is 1, this thing is 1. Then you create a parent. So 1 plus 1, 2. This is your current structure of the tree. This is gone, this is gone. Then comes C. So for C, you say 1, right? So C 1 and 2 L 1 T 1, and you add those things and it becomes 3. If I understand that correctly, this is how you build up the tree. And at a certain point, you would say this is the highest one. We can build a tree actually, right? So there is how many levels? 1, 2, 3, 4, 5, 6. 6 characters. So this is this. That would be this. Third character. Okay, we need some more space. So let's remove this guy. So this is L, this is D, this is C, this is O, this is D, and then this is my bad, E. So this is 1 and 1, so this is 2, this is 1 1 1 2, so this becomes 3 4 5 7, and then you can say 0. So if you go left, it's 0. If you go right, it's 1 0 1 0 1 0 1 0 1. So encoding of E would be 0. Sorry. Encoding of E would be 0. Then it would be D would be 1 0. Then this would be 1 1 0, something like that. It would be something like this if I get it right. We did the other way around, so it's fine. So this is where we need to have two things. One, the table. So we have to generate the table. And the second thing is we have to go over this entire structure, lead code, and encode it using this table. I think I understand that correctly. The problem here is that this guy can be huge. We have 32 bits, well, technically 64 bits if you take a long, but it can be more than 64 characters, which means 64 levels. So it can be more than 64, so it would overflow. So we have to think in that way. That's one thing. So we can always take a byte array. We can always take a byte array and do this thing where well, we can say the program is memory intensive, but the payload is not. Right. So that is one thing, because in the program I can store these things as string buffers, and then I can iterate over them, and then I can encode it into byte array. That I think might make sense. Hopefully. So let's try to do this, but we also need something which we can encode, which we can compress. So chat, what is a good huge giant text that we can encode? What's a huge giant text that we can encode? Yeah, something like this. We have it. Okay. we have, and if we look at not number of lines but number of byte count, I think is b m. Yeah, so it is can I just do h, by the way? How can I do size? We can do this. Yeah, so it's 1.1 megabyte, 1.1 MB. Now we can take this number, so for us it should come at around 245 KB. Wait, right? That's what. Yeah. No, yeah, 245 KB. So this is what we should be targeting. Close enough, right? So 1.1 MB to 2.245 MB. Okay. So this, I think, what we should target. So I think let's get started with our coding, right? Let's get started with our coding. So here we have for the Huffman tree, so no, okay. So what is a node? A node here, a node here is a character and int frequency, but this is a leaf node. And a normal node here is a frequency and a left and right. Right. So let's encode. Is it encoding? Do they use the word encode here? We have to return back something which we don't still know what we have to return back. Okay? We'll see what we have to return back as of now. So for now, let me quickly see where my food is, because okay, so I had to get up to order some food for the night. Okay, but anyways, so you have encode of data. So the very first thing we have to do is we have to tokenize it. If you look at this thing in here, we have to kind of tokenize everything, right? We have to kind of tokenize the comma, we have to kind of tokenize the space and everything, because we try to recreate the two files, right? So private int private map character, let's take it long, generate frequency map. And you know what, I do want to do just like this. Okay, Let's also do proper object-oriented programming. Hmm. So this is this. Map.compute. Put in the character and you get the value and you say if v is null, put in 1, else you say v plus 1. This is how you do thing. Return a map. Okay. Oh, okay. Yeah, I was looking to find it. My bad. Looking to find it. But yeah, we can also note this. General frequency map, and we can just say this here is we can do that. Okay, so how would you read this? I completely forgot how to read stuff. Buffered input stream. Here you have to give this. You can say file dot get stream or something. Okay, you don't have that. How do you? I completely forgot shit. New file input stream, and you have to do the file. And what you can do, I remember, you can take this entire thing in here. Catch. Sorry. we read it. So here, if I just say shakespeare.txt, it's gonna give a huge giant file. One thing we can do here is look at that. This is in fact what we have read. 1115395. Okay. Okay, so we have been able to read this. We can simply say new Huffman compression generate this thing. Okay, so what? Acha. So we have a space, we have R, we have D. Okay, cool. What you can now in fact do here is that the way we can pull together this thing is we can create a priority queue. Just a second. I'll just go get my dinner. since I got up, I also got some tea to keep myself going. Okay. So where were we? So we got a priority queue because this makes sense. Oh, where's my chair down? Yeah, okay. So now what we have to do is yeah, we can take the leaf node itself as this thing, right? So here let's make this private just to be compliant. What we can do is it's a priority queue of leaf node. Right. So for entry, ch is this, and we of course want a long frequency. So but here's the thing, comparator dot compare long one other thing here is that these I feel can be a record. Long frequency. It's simply a data folder. So leaf node frequency. So it's gonna be sorted by frequency, right? PQ offer this thing. Okay. Now we have to. What if it's just one word? I mean, who would one character? Who would try to encode a single character? Right? That's stupid. So we're gonna take that edge case later on. If data.length is less than 2. Yeah, okay. I think that's fair enough. All right. So one thing we can do is we can print this guy. And another thing I think is because we will have the same number of nodes as this, we can say it's frequency map dot size. Can you go to editor code style and have it 80? It doesn't quite wrap it, but okay, that's fine, I suppose. So let's print this. 1 1 1 1 1, all of those stuff. Okay, cool. So now I'm gonna say leave node left is gonna be PQ pole, and right is gonna be another pole. Now, why it's not empty? We're gonna have to do something more in here, I suppose. So this also has to be long. Let's make it private. Private. It's not gonna be a node. It's gonna be a leaf node. But here's the thing. So for them, one of them will be a leaf node, one of them, this would be a leaf node child, this would be a normal node child, right? So we have to think in that way. How can we do that? Let's call it parent node. Okay. Can you just shut up? Okay. And private interface node. Let's call it a Huffman node. Okay. Can this guy implement Huffman node? Can you do like that? You do it like, okay, you do it like that. Okay. So implements Huffman node. Now I can say this is a Huffman node. This is gonna be right. That's pretty much it. Now we need a parent node, which is gonna be leaf node left, leaf node right. That is correct. That's correct. That is correct. Cool. So what we have to do in here is that we cannot directly say this is a Huffman node. Huffman node. We have to say it in this way. What you're crying about? Why is it a problem? No, I can say this because then I can cast it here without an issue. I suppose. New parent node. So here I have to give left and right. Assignment might be null. Yeah, it's not gonna be null. We know for sure. We know for sure. Okay. So here, why can't it figure out that I already did this check? Because that is not the correct check. That is not the correct check. That's why. If frequency map or size is less than 2, so for now we're gonna do that. Wait. Yeah. So still can't figure out that. Oh, it has to be, but yeah, okay. So then what I have to do is PQ hole. So this is a leaf node, which is gonna be the left child. And in here it's kind of sus, honestly. How about instead of abstract class, and this can go here. We call this super. Stems. It's kind of sus that we don't have unions. I would really want a union, but I don't have that in Java. Questions, how can I do that? Okay. But it's a leaf node, so you also need this, and okay, this thing, right? And you need a getters and setters and stuff like that. Okay. Okay. What else do we want to do? So now, since you have this thing, I also want to say Huffman. So let's call it abstract node. Sidelism. Hello, 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 hello. Welcome to the stream. How are you doing today? Welcome, welcome. How are you doing? How's your Sunday going? Huffman node. Let's just say this. Right. Yeah. So this has to be fine. Can you add? What did it add? Why is it protected? So public structure, right? So here, private final Huffman abstract node, right? So Huffman abstract node, left and right. But technically, we can say Huffman leaf node, Why is it called leaf abstract? Okay. Right. So super is left dot frequency plus right dot get frequency, but this is kind of wrong. So this is Huffman abstract node. Huffman abstract node, because the children can be a normal leaf node or can be a normal node, right? So this is how your listing would be. I suppose I'll remove everything in here. So this here would be a Huffman leaf node. Okay. What is my dad sending? Yeah. Okay. So this here would be a Huffman leaf node. Makes sense. Huffman leaf node. And then here, this would be a Huffman node. Yes. What I was saying, these are potentially null. Okay, so objects dot require non-null. Are you happy? How does it assume that it's going to be null? Because I do new. I don't know. I just don't know. Okay, so this is going to be the left child that you have pulled out. What is the right child? The right child is the previous root. Okay. Huffman node next root would new Huffman left child, and not the right, but the root. Oh, that's wrong. Okay. So now everything is good. Now everything is good. And then what you do is you can say that root equals next root. That should be it. Yeah, that makes sense. That kind of makes sense. Right? That kind of makes sense? Kind of makes sense to me. So I wish we had a way to print this. Okay, so let's compile and see if everything compiles fine. Can you just run it? Okay, it works fine, blah, 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 yada, yada, yada. What am I printing that is saying that it's empty? PQ. This is fine because we have pulled out everything out of the system, right? So that's fine. Okay. Now what do we do? Now we have to go each level on either side, and we have to append something to the map. One thing I think is private point generate prefix. Okay, string hello 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 hello. So here we would like to say that take the half-man abstract node root and um, byte b, and we need a different way of encoding. How do we do that? How do we accumulate the data? How do we accumulate the data? So we of course have there's something called byte buffer. Okay. Let's have a heap byte buffer. A couple of unsafe things and all that. Okay. I think so. What we can do in here is a string builder. And let's just say string for now, because this is where we can actually start logging things and seeing things, right? If root instance of half-man leaf node, if this is the case, what do we do? The very first thing I suppose is prefix append p. Okay. So if this is the case in here, what you do is you say prefix map dot put. You take, so let's call this the node. Node dot character and prefix to string, and you simply can return from here. Suppose, right? Okay. If not, if not, you have to go left and you have to go right. So you have to say generate prefix. It's node dot half-man node. You cast it. Get okay. Get left. So left is you can simply say 0. I have to cast it, I suppose. And for right, you can simply say 1. One of the things we can do is we can just say int. Okay. So here, prefix builder. And in here, you can say this is the prefix. Okay. Yeah. So you don't have to do all this kind of stupid casting and all that. So if you go left, it's 0. If you go right, it's 1. Right. So we have to make this call in here. So you have to pass in this thing. This would be 0. This would be hash map, so we have to go to prefix map and then prefix builder. Right, and this here would be this. Okay, cool. So now I want to look at this. So is it still English? Yes, it's still English. If I go here, why didn't you go beyond? And why is L001? I know why. So once you do this, you have to say prefix builder dot delete character at this thing, and you have to do it here also. So this is basically backtracking, right? You have to do that, but it still kind of is sus that we do that. Huh? What is the issue here? Require what? Yeah, I gave it a. What are you talking about? Oh, wait. The fuck? अरे यार. Okay. Now I think we are going somewhere. No. L is 0, 0. Okay. And then you have a space which has a bunch of things. Okay. Okay, and none of them are repeating. One of the ways to check that none of them are repeating is prefix map dot values dot size is equal to new hash set prefix map dot values dot size. Yeah, it's true. So it's good that every one of them are unique, so we should be good here. So we have the table. So we generated the table. Now we have to somehow encode it into our thing, right? We have to encode it into our thing. This is where the tough question is: how do we do that? How do we do that? Any questions till now of what I just did, or like how this is working? We can do one thing to quickly test, I think, because I was looking here. We can check this and say that, okay, English is this. Well, and no new lines. No new lines. If I just run it, sorry. Well, I didn't do that. So if I do this in here, so see, S is 0, then you have L, which is 1, 0. Aha, aha. I think I get it. I have to append it here, don't I? No, but then that's a bit weird. I have to do it here. What? From where did this come? Acha. But I just appended this thing, so why would this fail? I know why, because why am I doing it twice? I just have to backtrack once. Man, I'm a little dumb. Okay, so S is 0. S is 0. L is 1, 0. It has to be 1 0. Why is it 0 1? Why are you appending? So wait, what? E should be 1 1 1. E here is 0 1 1. O here is also 0 1 1. So it's wrong. What the fuck just happened? So from the root, this thing would never when do you append it? Okay, I get it. So you append 0 in here and then you backtrack it. You append 1 in here and then you backtrack it. I think that is the correct way. Yeah. So E here is 1 1 1 and O is 1 1 0. I mean, that's fair enough. You just change that. Yeah, okay, so this is correct now. Okay, so this is correct now. I had a brain fart. My bad. Sorry, I had a brain fart. I did have a brain fart. But why is this prefix not being used anymore? I don't think you need a prefix because you always exactly know that for left you would. It doesn't matter where you're coming from. It matters where you're going. Right, it matters where you're going. So here, now this makes sense, doesn't it? Yeah, it makes sense. Okay, cool. तुम्हारा एग्जाम हो गया? Okay. I'm damn hungry. I'm just waiting for my wife to complete some work. But yeah. Okay. So now the important question here is that what do we do next? We have to somehow encode this entire thing, right? So we can keep appending it as a what to say, like so lossless here is what is the size. It's 8 bytes. Okay, and you can have that in 64 bits, which again is 8 bytes. But you can encode it using 14 bits. Okay. But how do I have to also save the dictionary. Where is my... Yeah, I also have to save the dictionary. Well, there are two things to this. One, the dictionary itself, that's one thing. The dictionary itself. The dictionary itself and the data itself, right? Now, if you're encoding the data using the dictionary, now I have to iterate over the entire data. And one by one, I have to say, oh, what is the prefix? And then I have to do something with it. And for Hmm. Okay. Okay. How was it? मैं नूडल्स और सूप ऑर्डर कर दिया हाँ. How was it? हाँ? क्या क्वेश्चन आए थे? That's okay. Okay, I'll just be back in a second. क्या क्वेश्चन आया? Okay. Yeah, I think I'm gonna take a break. Like I'm gonna stop streaming. In the night I might stream
I'm gonna
again.
stop streaming.
Not sure. But yeah, the reason why I'm breaking stream is stopping the stream is that yeah, I'm gonna go have dinner and after that I'll see if I still have energy left, and if I want to stream, then I'll do stream and I'll try and complete this Huffman thing today. So yeah, thank you so much for everybody who joined, and yeah, see you soon. Bye bye, and like, share, subscribe if you want. It helps the channel grow, and you know, it also helps recommend to people who want and would like this kind of content. So yeah, thank you so much, and see you soon. Bye bye.